Hi everyone, this is Ashish Dhyani and today we are discussing about Android architecture. So we all have heard about Android, what the operating system that we use in mobile phones, right? So Android operating system for touchscreen devices, they present many challenges that must be overcome during development. So in a way, the architecture of Android platform is a set of software components designed to support the large number of Android enabled devices. This mobile operating system is based on a multi-tiered architecture of software stacks using Linux, kernel, runtime environment, libraries, frameworks of applications, and different applications. Right? So when you are building a complex system like this, you need to pay close attention to the structure so that all Android architect components do not conflict with each other. Right, overall the Android architecture protect many components from crashes, right? So Android layered architecture, they have some benefits, right? So what are those? Having Android layered architecture allows different issues to be categorized and addressed at different levels. Android software development can avoid low-level problems in all development using a layered architecture. Instead, you can focus on delivering business values that is relevant to the level you are working on. Rather than working on the details, developers working on the apps, they don't have to worry about actual implementation of the application framework. These responsibilities fall to the system architect, which is responsible for implementing the application framework. Because of this hierarchical Android model, updates containing bug fixes and improvement can be applied to each tier separately, right? So developers at different layers of operating system can work together without interfering with each other. And this is especially important when new versions of operating systems are updated and released, right? So we have different parts of Android architectures. So the first one is Linux kernel, right? So like any other operating system, the Linux kernel or whatever we call it in this context is one of the most important components of the Android architecture, which is sitting at the root or you can say lowest level of the entire system. It manages all the drivers your Android device needs at runtime, right? Camera drivers you need display drivers, audio drivers, Bluetooth drivers, storage drivers, right? Now the main feature of Linux kernel is like the Linux kernel provides you security between applications and host system. So memory management it also provides. Efficient memory management, which allows you to develop your own application without worrying about memory allocation. Process management, effectively manage the workflow process and allocate resources when the process requires it. Then network stack. It has ability to effectively and efficiently handle network communications. And one of the Linux key features to support for multitasking. As a multitasking operating system with asynchronous execution. Multiple processes can share the same CPU and other resources sequentially. So CPUs are designed to do only one task at a time, but in Android you can do multiple tasks, right? Then you have next thing, which is platform libraries or native libraries. So several native libraries are layered on the top of Linux kernel. The library provides device with a set of instructions that allow it to process various types of data in an appropriate way. And these libraries are required as a part of Android development. This is a collection of C or C++ code libraries and Java-based libraries that support Android development. Graphics, libc, SSL, SQLite, OpenGL, WebKit, Surface Manager, lots of things are there, right? So, media library for playing, recording and editing audio and video formats. A Surface Manager library provides you display management functionality. OpenGL library and SGL library is used to create 2D and 3D graphics. SQLite supports databases. The free type supports fonts. Secure socket layer keeps the internet secure and WebKit provides you browser support. Right? So these are the libraries. Now the next thing that we have is Android runtime. So Android runtime is what? It is an integral part of Android. It includes components like your whole core library and Dalvik virtual machine. So the Android runtime along with libraries, it supports applications that are foundation of framework. Similar to JVM, Java Virtual Machine, the Dalvik virtual machine is a virtual machine used by Android to run applications. Android uses DVM to optimize battery, memory usage, and performance also. So special design and optimizations make it easy to run multiple instances simultaneously on Android devices. It relies on the Linux kernel to handle threading, low-level memory management. This improves performance and reduces memory consumption. Android runtime provides core libraries that an Android application developer can use to develop his applications using the Java programming language. The next thing that we have is application framework. So application framework sits on the top of native library and runtime layers. It provides high-level application programming interface and services. The Android application framework provides classes, interfaces, and utilities that are used to develop Android applications. The framework also includes the Android hardware abstraction layer, which allows application to communicate with hardware-specific device drivers, manage both user and interface and resources. The overall goal is to provide a service that allows you to create specific class and use that specific class as an aid in building your application. Then you have applications. Beneath the layers of Android architecture, applications are at the top. Right? Applications pre-installed on the device such as contacts, music, app store, your cameras, galleries, applications that you download from Google Play Store, social applications, games, professional applications, right, are installed at this level. So application in the runtime environment and make use of classes and services provided by application framework. A typical user will interact with layers primarily for basic functions like accessing the web browser, making phone calls, viewing galleries. So these are all the layers of Android architecture. Thank you.